Yes, please. Let's start this math lesson. Alright guys, so today we are going to talk about slope and similar triangles. So basically, it's easy, but we're combining slope, proportions, and triangles. So on the next video little slide, I'm going to give you some points that we're going to plot on here to the best of my ability. I don't have a coordinate plane board, but if I did, we'd be showing it on that. So we're going to plot some points, make them a triangle, and then what we're going to do is we're going to take sides, set up a proportion, and figure out what would the slope be. It's a lot of steps. I'm not going to sit here and tell you this is not a lot of work. It is some work today, but it is easy. It's not hard work. So I think you guys will be really pleased with how easy it is. And I just got some graph paper and put it on graph paper and graphed these triangles. So we'll start right here. I have triangle ABC. A's plot is -1, 2, and you can see I put a dot there. B's point is +5, +4, which is up here, letter B. C's point is 5, +5, +2, which is right there. I connected the triangle. Then we have triangle QRS. Q is -4, +1. So I went in a negative direction on the number line and then up in a positive direction for Q. Then there is R, which is +8, +5. So I came over to 8 and then I went up 5 and that would be R. And S is +8, +1. So I go over 8, 1. Okay. So what we need to learn is or realize is that these are similar triangles. So that means they're proportional. So the slope of these triangles is going to be the same. And when we're talking about slope, remember we've discussed this, that slope is M, and we'll get to that probably tomorrow when you come. But the slope is always the up and down. It's always the up and down. And then on the bottom is, oops, I don't know why I did that, is the run, which direction it goes, left or right, okay? We also need to remember that we figured out, we've learned that slope M is equal to y2 minus y1 over x2 minus x1, which is actually the change in y over the change in x. So it really doesn't matter if you have 2 first or 1 first. It really doesn't matter, but that's what it is. So what we're going to do is, I did not mean to do that. We look over here and we're looking at QRS's rise, okay, triangle QRS's rise. Their rise, their up and down is RT, okay? This is the rise, okay? Now, triangle ABC's rise is BC, which is right here, right? Okay? Let me make that a little better. I apologize. This is triangle ABC's rise. Okay, so we have appropriately named it RT over here, and then for this one is BC. Okay, so I'm going to go ahead and put RT is 1, 2, 3, 4. Don't know why I'm doing this with my hand, guys, so I apologize. So that's going to be 4 over, and then down here, triangle ABC's rise, the BC is 1, 2. So that one is 2. See if that shows up. Okay. All right, next, let me change colors for this one. And I'll pick a green. Okay. Next is the run. And triangle QRS's run is QT. So this is the run. It doesn't show up very well, does it? Okay, this is the run. And we can count that by starting at Q. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's 12 hops from each. So this slope of QRS is 412. And then ABC's run is AC. And we'll start that by 1, 2, 3, 4, 5, 6. 2, 6. All right, so these aren't the same slope, right? By looking at it, the 412 is not the same as 2, 6. But what happens if I come over here, we have some space, 412 is equal to 2, 6. I'm just going to prove that they are proportional, because if we change colors again, let's do light blue. If we cross multiply, 4 times 6 is 24, and 12 times 2 is 24. We see that those slopes are in fact equivalent. So we can actually reduce, and I like to reduce the smallest one first, or simplify, sorry, and we'll simplify by 2 over 2. Okay, and 2 divided by 2 is 1, and 6 divided by 2 is 3. So 1/3. 1 over 3 is our slope for this line. And I'm going to leave this right here, and I may come back to it in a little bit to show you another way, how it works. But if you look, if I go up 1, because that is telling me this 1 right here, sorry, it's not showing. This 1 right here is my rise. So I go up 1, and then the 3 tells me to go over. So up 1, and then over 1, 2, 3, and I hit the line. Then up 1, well, why is it not showing? 1, and then over 3. 1, 2, 3. I hit the line. Then up 1, 1, 2, 3. Hit the line. Up 1, 1, 2, 3. Okay. Which this doesn't show very well because I'm using my finger on my computer. But if you have any questions about finding it, just remember, you have to remember that slope is rise over run, rise over run. Okay, and I'm going to show you a little bit of a different example in just a second. Slope is still the same. It's still rise over run. It's always M. And you can find it by doing the change in Y over the change in X. It's always up and down over left to right. Okay, so this one's a little bit different because the triangles are not connected like the last example. If you want to double check my triangular points coordinates, go ahead. I have them done. So this is going to be a little bit different. Some of you may find it easier, but I'm going to do a different way to find the slope. So I'm going to, remember, it is rise over run. So we go up or down first. So I'm going up 1, 2, because the slope is to right here. Sorry, it's not showing up. All right. So for RST, it is 2. Okay. The rise is. So let me look at the rise, because remember, it's going to be from here to here. Okay. So the rise for XYZ is 1, 2, 3, 4. So it is 4 is the rise, and I'm going to change colors for my run. Okay. Now my run is, what direction am I moving if I'm going this way? On the number line, that is a negative direction. So now I'm going 1, 2, 3. But it is a negative 3. That does not look good. Let me delete that. Negative 3. That's better. All right, now, and over here is 1, 2, 3, 4, 5, 6. And again, I'm going in a negative direction, -6. Okay, so taking out the negatives, we'll leave them there. We're going to compare these because they're proportional. That's what we're saying, because they are similar triangles, so their slopes are going to be proportional. It doesn't matter if the negative's on top or bottom. All right, so if we were to cross multiply, 6 times -2 is -12, and 3 times -4 is -12, okay? So the slope in my most reduced form would be this one right here, 2 over -3, okay? Now you could actually go down 2 and then to the right 3. That would work too, because you could go 1, 2, and then 1, 2, 3, and you're still going from point to point. I'm going to show y'all something else real quick. Let me clear this stuff. And I'm going to try my best to do this with a steady hand. So if you look at this, these triangles are on this line right here. And that's the best I can do, so don't judge me. So if I wanted, we said our slope was -2, +3, right? Or it could be +2, -3, either way. So we could also do, if we use this one, if we went down to 1, 2, and then over 3, 1, 2, 3, I made a new triangle, okay? This triangle would also be considered similar, and we could go down. Or you could also look at it like this. I could go up 2 over 3. This triangle right here would be similar to this one and this one, okay? So there's different ways that you can find the slope, whichever one feels comfortable to you, whichever one you like use. If you have a question on this, just pause and raise your hand and I will come help you if you're virtual.